Factoring polynomials by taking out the GCF, Part 2. So factor 3m plus 3. First step is to find the GCF, which is going to be a 3. We'll take it on the outside, make our parentheses, and to get back in there, remember you have to have as many terms as the original problem. So inside we have to have 2 terms. For the first term, you have the 3, you're missing the m. For the second term, you already have the 3 on the outside. What number could you multiply by to get back to 3? It would be a 1. So you have to put the 1 in here. Let's check it by distributing. 3 times m is 3m, and 3 times 1 is 3. It is standard practice if you have a negative on your first term when factoring to choose a negative GCF. So we will choose a negative GCF this time because our first term is negative. So we're going to choose a negative. For the numbers, we can't use a 9 because it doesn't go into 15. We'll have to go smaller. How about a 3? 3 divides evenly into both. For the A's, we have A in both. Go with the smallest, so we can take an A and we can take an X. That's our GCF. 1 set of parentheses. Inside, you're going to need 2 terms to get back there, and we'll just be a little careful with the signs. So first of all, we have a negative 3. We want a negative 15. Multiply by 5. For your variables, you have 1a outside. You want a squared, so you need another a. And you have the x on the outside. For the next term, you have a negative 3. You want a positive 9. You would have to multiply by a negative 3. The a is good. The x is good. Let's distribute back to check to make sure our signs are right. So we'll distribute the negative 3ax times each term. We get negative 15 a squared x. And then we get a positive 9 ax, and that matches our original, so we are correct. Let's look at this example. We're going to factor, and it does start out with a negative term, so we're going to choose a negative GCF again. For our numbers, 21 does not go into 49, so a 7 is going to be our number part for our GCF. For our variables, we can do an x squared and a y. So that will be our GCF. Make our parentheses and then try to get back there. For our first number, we would need to multiply by a 3 to get negative 21. We have x squared, we want x cubed, so we need an x, and we have the y outside. For your next term, you have a negative 7. You want a negative 49. So you're going to need to multiply by a positive 7. The x squared is good. You have it outside, and you need one more y. For our check, we'll distribute back. So we're going to have negative 21, x cubed, y, and here you will have a negative 49, x squared, y squared. So it does check. Looking at this problem, it looks different than the others. If we did not have the directions that say factor there, we would distribute. In general, though, if it says factor, don't distribute. So the only kind of factoring we know how to do right now is to take out a GCF. So we look at these to see if there is anything the same. And there actually is something the same. It is this big group. So the 2x plus 1 is the same. We can take it out. That is our GCF. And then to get back there, this was only 2 terms because terms are separated by the signs. So our GCF is on the outside. To get back there for the first term, we have the 2x plus 1. we're missing the 5x. And for the second term, we have the 2x plus 1 on the outside. We're missing the minus 3. For this kind, I would not bother to check. Your check takes too much work. You would have to do a FOIL to multiply your binomials, and you would have to multiply out your original to get them to match. Let's look at one more problem, and it does say factor, so we're not going to multiply out. And this one also has that common binomial, so it has this large piece that matches. So we will take it out. That's our GCF. To get back there, remember we'll have as many terms as the original problem, which had 2. So for the first term, we have the 5x minus 2. We're missing the 4x squared. For the second term, we have the 5x minus 2, but we have to multiply by something. If you don't see anything on the outside, then you would multiply by 1 to get back there.